Hello everyone, welcome back. So today we'll be trying to do maze generation. I've taken a look at the Wikipedia page. It seems pretty straightforward. I'll be explaining it on the whiteboard. Let's take a look at the video here. This is using hexagons, but we'll just be using squares, though it shouldn't really change the concept itself. So explaining it while watching the video, it's basically starting from any given cell. Normally you would take like one corner. So a corner cell, you randomly select any of the neighbors around it that are still not visited. If there is no unvisited neighbor around you, you go back from where you came from until you find unvisited neighbors, and you do that until there is no more unvisited neighbor, basically. So that's how I understand it. So let's go on the whiteboard and try to get something out of our heads, how to get this working, right? So we'll have some type of grid, right? So we'll have like I won't be drawing the grid again. I've done this a couple of times already, so we'll just be writing the pseudocode we think of doing, right? So we'll have some type of grid. It'll be a 2D array, right? I'll just do that just so we understand. 2D array of cells. So now we'll be starting at, let's say, 0, 0. 0 index 0, right? This will be the starting cell, and then we need some type of function for getting the so each cells here, right, needs to know if it was visited or not, right? If it has been visited or not, right? So we could just have like a false value in there and set it to true whenever it's visited, right? So we could say false by default, right? False by default. Okay, and true when visited. All right. We need also an array that keep tracks of the trail, right, of the previous visited, the previous cell we were on, right? So we need some type of current cell. So we can call this maybe current. And it could just current, and it could just keep track of the X and Y we're currently in. And we need some type of trail, right? Trail, which will just be an array of X, Y, or column, row, whatever you want to call it. Great. And we need to push to it every time we change the current. So we'll need a function, so next. So we'll need a next function, which will basically get called after you've done the previous next. Next will return, let's say it returns like null. Well, let's not care what it returns for the moment. So next should select one of the unvisited neighbors around it, right? So I'm thinking we could just have a quick function that returns us. It's not going to be efficient code for sure, but I'll leave that up to you to refactor it, make it better. So we'll have a function that gets all the unvisited, right? So get unvisited. Sure. This function should just go through go through the grid and filter only the false one. The false, sure, that's fine. And technically, we could just get unvisited and pass it, right, like an array. Neighbor. I'll just call it n, short n, it's going to be easier. So n here, it's going to be the neighbors. So get unvisited and then passing it all of the neighbors. All right, so next, it knows the current value, right? Let me draw a better arrow over here. Need to find a better marker. This one's getting a bit dry. Well, it's dry markers, but you know what I'm saying. All right, so next we need to get the neighbors, right? We could do it just manually. It's just going to be x plus 1 and y plus 1 and x minus 1, so on and so forth, right? Or we could just do a for loop for x equals current x minus 1, x is smaller than the current x plus 1 and smaller or equal to the current x plus 1, x plus plus, right? And do the same for the y. Get those into like a neighbor array, pass that neighbor array to get unvisited, and then query get random cell parentheses xy from result of get unvisited. There you go, right? Let me see if I have some dark color here. Yeah, that should be fine. Yeah, that's great. Okay. Okay, great. So that's pretty much the idea. And now, if the result here we get an empty array from this function, we can just pop the last element of trail and set the current to that, basically. I think that's pretty much the idea. So the other thing will be after that will be to remove the edges, right? That we can think of afterwards. Maybe, yeah. I'm thinking every time I go, let's say current is here and all of them around it. And neighbor is important. Neighbors is not going to, we might want to not use the loop because neighbor is not going to include the corner pieces. So the for loop will include those. So we might not want to do a for loop to get the neighbors. We could just hard code for values. So x minus 1, same y. X plus 1, same y. Y minus 1, same x. Y plus 1, same x. But I'm thinking every time I move through here, let's say the next current is up top, I would need to remove this barrier, right? Right now I'm not, well, could be a good idea to remove the walls. I'm just thinking how to go about removing those walls, right? Well, we could just have, instead of true or false, we could have some type of object that has visited, which is false by default, and we'll base ourselves on this value instead of just the square itself. And then it could also have like walls. walls, which would be, let's say, an array which would have, let's say, in quotes, in string, like top, not top, bottom, so on and so forth, right? And we could just remove whichever one we want from here. And it might be easier for me to do it with just another object. Not another object, but just more properties. It'll be easier to access. So we could just have, let me just try it out. Okay, we could just have top be true, let's say. Bottom true, so on and so forth, right? So let's do that, but not remove the walls to begin with, and we'll remove the walls at the end, let's say. Okay, so let's try this. Okay, now let's first create the array, right? So we have const grid or board, whatever you want to call it. Both of them are fine. And we'll need some type of scale. Let's say a scale 50 for the moment, like a big scale. I just want to get the concept working first. So we'll have variable for the columns and the rows. Oh, let me mute as well this cell. Okay, that calls rows. Okay, good. Now let's calculate the amount of columns, which will be the width divided by the scale. Okay, great. And the rows will be pretty much the same thing, but for the height, with the height. There we go. Okay, now let's loop over all of the calls and row we would have. In this loop, we might do it a couple, well, no, you shouldn't do it that much. Anyway, doesn't matter. Call equals 0. Call is less than the columns. Call plus plus, there we go. Let's do the same for the row. Let row equals 0. Row is less than rows. Row plus plus, there we go, awesome. And here we'll need to do grid index call equals an array. And here grid index call index row should equal, like we said, an object which initially has visited to false and has not visited, there we go, and has all of these sides to true. Top, bottom, left, and right. There we go. Okay, great. Okay, awesome. Let me do like a white background. And let me get this array again. And instead of this, we'll just call this cell. Okay, great. So now cell, we can get, we can just draw, let's say, 4 lines. Line that goes, so 4 lines. First one will start at calls times, and I'll just get X and Y, which it's just pretty much going to be call times scale. And same thing for the Y, but it'll be with the row. There you go. So the first one should start at x, y, when going across. So it should just be, let me make a quick variable for the scale itself. Let me do like something like, sure, that's fine. SCL config.scl, there we go. Just so that I don't have to type config all the time. There we go. Okay, great. Okay, now let's go down again. Okay, great. So now next point should be at the same y, but it should be not at the same x, should be to the right, so it should be x plus scale. Great. Now the next line, yeah, so that makes sense. So the next line should be starting from the previous ending point of the previous line, going down, so it should be the same but plus on the y. And now this should be the starting point of the other one. This, but going to the left, which would mean removing this. And now this one should go from here to the beginning point, right? X, Y. Wait, I'm missing something. So here, oh, no, we need to start from this, right? Yeah. There you go. Okay, I think we're good. So now we have all of the sides done for our scale. That's good. Okay, so let's think about this. So I want the current, I want some type of current, right? So let's do let current be equal to an array, which would have like, let's say x, y, so, or col and row. So let's say we start at the top leftmost cell. So now let's make a function that's called next. Okay, there we go. And I will also want to keep track of the trail, right? Const trail equals an empty array to start with. And it doesn't need to be an empty array, it could be starting with current. That would make a bit more sense. Okay, so now let's say something like if, let's say, yeah, okay, wait, sorry. So let's say in here, if cell dot or grid index call index row dot visited, then let's do fill, I don't know, some type of color. Let's do like some type of magenta / red. Let's do like 67, and the last one should be like something a lot more, like 130. Okay, sure. And let's do a rectangle at xy, going cross scale in both direction. Okay, so, oh yeah, and wait, does that make sense actually? This one is not even visited. What's the issue? Let's take a look. Type error, cannot read property of undefined reading visited. Reading visited. So this is non-existent, it seems. Okay, that's interesting. Oh, there we go. I need to remove this. Okay, great. So now, and let's set the first one to, let's say, col equals 0 and row equals 0 as well. There, okay. So this one is visited right now. So let's do Okay, now we have our next function. Like we said, in our next function, we want to get the neighbors, right? And I'll just call it n, so that it's just easier to type. Okay, so n is an array. So now we need to get all the 4 surrounding neighbors, not the 8 surrounding neighbors. So it's only the neighbors, non-diagonal neighbors, I guess. So we'll do if and I'll have like const c equal current just to make my life a little bit easier, or call equal current index 0 and row equals current index 1. So if call -1, which is the left neighbor, is smaller than 0, is not smaller than 0, sorry, so greater or equal to 0, then do this. So n dot push, and then you push an array containing call, comma row, and it's going to be call -1, right? So let's do this 4 times. So next one will be call +1, but this time we want to make sure that it doesn't go over the calls, smaller than calls, I guess. Okay, and here it'll be +1, and then we'll do the same but for row. There we go. Row, rows, and here it needs to be call and row -1, and here it needs to be call and row +1. Okay, great. Like I said, this won't necessarily be the most efficient way to do. Well, it's definitely not going to be the most efficient way to do it, but that's how I'm going to go about it. Feel free to update the code, please do. It would help probably a lot whenever we're done. But for right now, it's fine, I guess. Great. Okay. So now we have the neighbors. Now we need to find only the non-visited neighbors. So we can do something like we can get the function get unvisited. I don't know if that's a term, but it's fine. And we'll get n, just an array of x, y coordinates. An array of vectors, basically. I could use vectors, but I'm good with that. So we'll just do we'll just do const unvisited, I guess, equals an array. And what we'll do is just do for let I is equal to 0 as long as I is less than n dot length I plus plus. And now we can just do if grid index, and now we need to do n index I index 0. A bit complicated, but we'll get there. And then same thing, but index 1 dot visited dot not visited, sorry. Or we could do visited and then just continue if it is. But not visited, let's do unvisited dot push n index I, right? I think return unvisited. There you go. Okay. So now we can call this function to get And we can do like let n be equal to this, and we can just do n equals to the result of this, right? That should work. Okay, now we can do if n dot length is equal to 0, I guess. Then do backtrack, right? Go back on your trail. I'll just put a comment. There we go. And otherwise, just do current equals random in n, and also let's do grid index current dot call current index 0, index current index 1 dot visited equals true, right? Does that make sense? I think it does. And here we just need to do basically this. Well, current equals trail.top, I guess. Let me just take a look at the MDN ref for array. Let's take a look at pop. I believe it returns the element. Yeah, it does return the element. That's great. That's exactly what we want. So trail pop, not only it removes it from the array, but it's also oh, and before setting the current in here, we should add it to the trail, right? I mean, since we're adding this one, I mean, we could not add it as well. That work? I think it would. So let's do trail dot push current before it gets changed. Okay, I think we're getting somewhere. Let me do something like calling next once every time in draw. I think it's working. It's difficult to know because we're not removing the borders, but if you take a look, it's going back right now to this one, then this one, then this one. Now it's going there, and now it's go. Yeah, I think it's working. Yeah, that's fine. Cannot read property of undefined reading property 0 of next. Yeah, that's fine. We'll worry about this later on. Let me just I'll be right back. And we'll do the borders, right? The edges. Where's the mouse? Okay, there it is. Just give me a second. Okay, I'm back. Sorry. So let's do the walls now. So removing the walls. We would only need to do it in this else statement over here, right? I believe, because if we're backtracking, we've already removed the wall, so it should be only in here, right? So okay, let's try this, right? So we'll have, again, it won't be efficient because I'll be having like if statements for the four possibilities, right? That's fine. Or we could have two. We'll see. Possibly four. I'll do it with four. I'm okay with that. Okay. So we need to know the trail last. Okay. So okay. We can say const last equal current. Okay. Here we'll set it last equals this. Yeah, I believe it's working, definitely. Right, it's going to go back there. Oh, not even, oh yeah, I'm not seeing under it. Anyway, that's fine. Okay, so now after setting the current, right, it's going to be over here somewhere. We need to say, well, okay, we already have this one. Okay, so how do I want to do this, right? Okay, let me think. So over here, I could just say visited is equal to true, and then I could say if current index 0 is, let's do it in 4. Oh, yeah, 4 is, so if current index 0, so call, is smaller than last index 0, that means we went to the left. I mean, current is to the left, right? That's like if we had last here and current was to the left. So we would need to remove the wall, the left wall, basically, for the current one. So it'll be grid for current dot left equals false, and at the same time we can do it but for the last and for the right wall, last and right wall. Right. No. I don't think it's working. Oh, well, yes, it should work if I were to put this properly, right? So we'll add back cell in here. Const cell equals grid index call index row, and then we can just add the if statement over here. So if, and then it's going to be like cell dot, this one is top, right, bottom, left, correct? I don't think so. Or I'm doing something wrong, which is also possible. Oh yeah, that's the difficult part, right? I guess the algorithm is pretty simple, but displaying it, it's a different thing. This should be right though. Why is it not doing this? Okay, let me do all of them, and we'll see. So else if current is greater, then we need to remove the right and this one left, correct? Yeah, I think so. Okay, and then we can do else if, and then it's going to be current index 1, last index 1. So whenever this current is smaller, which means we went up, current, it should be the bottom, and this one should be top, and then we can just inverse the both of them, right? This makes sense, I think. We'll see. Not sure. I mean, I'm never sure, but well, that doesn't matter. Top, bottom, right? And let me do, oh yeah, I think we see the stroke still because we have strokes, right? If I were to say no stroke, no, never mind, sorry. No stroke should only be in here and then there should be stroke for this. Stroke, I don't know, stroke 0 should be fine. There you go, and we'll do stroke weight of, I don't know, 3, something so we can see it. There you go, take a look. There's something wrong, definitely. I'm seeing it right here. You probably are also seeing it too. Okay, what is the issue actually? Okay, so one thing I want to do now is I want to do this before doing the strokes. So over here, seems like previous strokes are still there, or the algorithm is just not right. I think the algorithm is right. Let's do it. Let me floor this value first, just because I want to be able to see it. And like here it was going over the edges. And I want to do, yeah, that's not correct. See? Let me see. Last, index 0, index 1, top, bottom. Let me do it at like 5 frames per second. Going down, it's fine. Okay, so going to the right is not fine. Okay, so going to the right is not fine here. So whenever current is greater than last, current is greater than last, it's the left wall that should be removed. And this one should be the right one. Correct? Yes. Okay, and then same thing, but here, left, right. Okay, I think that's right. Let's make it go a lot faster now. Let's put it back to 30 frames per second, and we'll see. We'll let it run and see if we get a maze. Would be cool because that's what we're expecting. But I think we've got it down. So doing the actual algorithm was pretty easy. Getting the edges was a bit difficult. Not difficult, but you get what I mean. Okay, great, 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 great. So now this error is pretty much only because over here, I'm guessing I'm trying to pop the trail, and the trail is now empty, so it returns undefined. So what we could do is just if current is undefined, no wait, cannot read property of undefined reading 0. Yeah. So if current equals undefined, we can just do no loop return, right? Let's see, let's let it run. Oh, I mean, I still want to draw it, so possibly removing this and putting it before the next call. Yeah, that should be fine. Okay, one thing I want to do is I liked what they did in here, wherever the backtracking was different color than the visited one, right? So we can have something like Um, mhm. We could have something like here, over here, maybe we could set something like backed, which is false, and it's backed only if we popped it from the trail, right? So in trail dot push, no, that's fine. Trail dot pop over here, or you could say if current, just to be sure that current does exist. Then we can just do if current exists, then we can do grid index current index 0. And possibly it would be easier to understand the code with vectors. I would suggest for you to do it with vectors. Right now I'm just doing arrays of 2 elements for a column and row, but you could use just a vector with the x and y as being the column and row. That would also be totally fine. Would probably be more understandable, at least in the way that the code is more readable, but I'm fine with it. So this is true. I just wanted to get something working. So here, what we could say is we always want to draw the rectangle. The only thing that should change is the stroke, basically, right? That could be an option, right? So if visited, and this I've called it cell, so we can just do cell. Great, and I want to possibly put backed in here, cell dot backed, if that's the case, and then else if. There we go. Let's just try to do something like 162, I don't know, maybe like 87, and it's a little bit too similar. Let's do 55. No, I don't like that color. It's not a great color, to be honest. Yeah, it's not that good of color. Let's do 200 in here. What color do we get? Yeah, some type of yellow. I'm fine with that. Oh, and one thing I want to do is also set a base fill color. So we'll just do else fill some type of bluish color. So something like 40 or maybe like 98, 67, and like 190. I'm not great with colors, so I'm just, yeah, some kind of purple. That's good. So you see everywhere, it's kind of yellow. It's been backtracked, and eventually it'll all be that color, since it's going to backtrack up until the last one, up until there's nothing more in the trail, which should be basically all of the elements. But we can see the algorithm pretty much working as expected. Oh well, yeah, the edge pieces are not part of the trail, which I guess makes sense. But it's fine. That's not really an issue. Just gives you some type of color kind of look. I don't know. It's fine. You could also just remove that backed stuff. That was more for me. But I like the color though. So let me just do that color as the default color. So I'm not going to use that backed variable or attributes that I put. But anyway, this is maze generation using the backtracking, I guess, algorithm. I'm not sure what the algorithm name is. Depth first search algorithm. Using backtracking. I would suggest for you to try this, changing the colors, maybe trying different shapes, right? They were using hexagons, which you could use. It's pretty simple, I guess. It's the only thing that would change is getting the neighbor, right? Which neighbor, or how many, like who's the neighbors, right? That could be pretty simple to implement. Also, if you want to like make the code a lot more readable or better, that is also welcome. Um, Try something new, try something different. Hopefully you liked it. Thanks for watching. You can find the code in the description down below. Yeah, that's pretty much it. Leave a like if you liked the video. See you in the next one. Thank you.